So next up, we'll have a joint presentation. They're both in the data science and machine learning track. That's going to be Justin and Katherine. Please go ahead.
Okay, well, hello, CCE. So we are the data science and machine learning interns. My name is Justin.
And my name is Katherine, and we were supervised by our manager, Dr. Kunzan. So we wanted to give you a little bit about our backgrounds before we go into our capstone project and some of the things that we learned. So I actually have a bachelor's degree in biochemistry. A lot of my previous experience is in nonprofit work as well as sales. And so I've been trying to make this transition into the analytics and the data science fields. And so I thought this program would be perfect for that. I've been working on my San Jose State University Advanced Graduate Certificate in Business Analytics at the same time. And I'm happy to report that I actually received that last month. So super excited about that. Previous to this experience, I had no experience working in Python or utilizing Jupyter Notebooks, so that was very interesting. And my goals are to learn a little bit more and set myself up for an analytics or data science job in tech and healthcare.
Moving on. My background is that right now I'm a senior and I'm pursuing a bachelor's degree in economics with concentration in data analytics at Santa Clara University. I also am attending an extension course for UCSC certificate program for database and data analytics. With these experiences, I've become very well versed in Python 3 as well as Jupyter Notebook prior to joining this internship. And in the future, I'm interested in a data analyst position. Next slide, please. Besides our backgrounds, we also wanted to share Kun's background as well on his goals for us. So first of all, Kun, he's obviously very credible when it comes to teaching this internship because he's worked as director for data science at Expedia. And he also has prior background in operation research. So his original purpose for us, and I quote, is to demonstrate traditional data science project and share with both Katherine and I what the company will look at when approached by a possible data science candidate. And it's important to know that his goal basically shaped an entire program. He cleared the way to sort of show us how committed he was to teaching us machine learning and data science through multiple projects, and he gave the insights necessary for us to know what companies will look at and also share the experience working in the data science field. And during our time of internship, we definitely benefited from that. Okay, next slide, please.
So to give you a little bit more of an idea of what our role entails and what the main focuses were. So for Kun, he really wanted to make sure that we understood how data science plays within a company and how it intertwines with other company roles and just get more information about the field in general. He wanted to lay a good foundation for our Python and Jupyter Notebook experience just because Python and Jupyter Notebooks are utilized very heavily in the data science world. It was really important for us to be able to construct a data science project from start to finish utilizing models and algorithms, and then also to teach us some of the more nuanced tools and ways to make models a little bit more efficient and smaller things that you wouldn't necessarily learn in courses or in school. Next slide, please. Okay, perfect. So today we are going to be talking about our capstone project. And so I'll be talking a little bit about the hypothesis and the initial questions. Justin will go over our process, and then I'll talk about the results. So initially, we were utilizing a data set regarding housing prices, very not surprising given Kun's current company. And so our data set specifically was within the Iowa housing areas. It covered roughly 1,500 different houses. And also had over 80 variables. So it was fairly extensive in terms of what we were looking at. And our target was to be able to understand, the relationships between all these different variables as well as sales price and to be able to predict sales price efficiently. So Justin will go ahead and talk a little bit more about our process and what we did to take a look at the data.
Very quick, before we get into that, there's also some initial questions that we also wanted to share before we got into the process. Some initial questions. Can you go back to the previous slide? Sorry about that. Some initial questions we had before starting this project included sort of what are specific variables that link to higher sales price, which was the most predictive, most important ones. In specific cities within Iowa, which one outcomes were most similar, which caused outliers. which variables didn't matter at all. And also we wanted to learn more about the notebook, how we conducted linear modeling, and how we could actually predict sales price for all the attributes. Next slide. So with that in mind, let's move on to our process. Next slide. So here we have a timeline. Each of it has like steps, and each of them are the steps we took to building our final model. So first, it's important to point out step one, which is the data analysis we conducted. So what we did, like Katherine said, we took the housing data set that we got from Iowa, and with all the explanatory variables available, we had to first separate them into sort of numerical categorical variables, and we had to compare their relationships to sales price. Some relationships were obvious at first, like we can totally see how, like for example, how long the time took between a house being built or being remodeled and the sales date will lead to a lower sales price, just because the longer span of time it takes to remodel a house, the less is going to decline in quality. However, these relationships between large variables and sales price weren't always so clear cut. For example, unfortunately we don't have graphics to show you, but for a few variables, there's overall quality. It's an obvious normal relationship where you're able to see the higher rate and overall material used to build the house and finish it. Obviously, that's a higher sales price. However, for overall condition, for example, the grading system, essentially rating the overall condition of the house, we discovered higher rates don't necessarily correlate to higher prices. We could determine that by seeing that the relationship wasn't normally distributed as much as we thought it would. So by doing this, analyzing all our variables, we engineered these variables later to maximize the value of a linear model. And with that, we move to step two, feature engineering. So during this step, our team made sure to reevaluate all the relationships between variables, specifically between missing, numerical, categorical, all of them on sales price. This is just to determine which variables we're going to use that would present more of a predictive impact on the overall model. And we later determined that there was actually a huge critical issue within the variables themselves, that a lot of the underrepresented variables were actually overfitting the data set. Essentially what happened is that there were a few variables that represent less than 1%, but since there were so many of them, they caused the overfitted, they caused the larger variables to have a skewed effect on the overall model. So what we did was that we had to transform them. We used multiple techniques such as logarithmic transformation, encoding, categorical variables. We helped this to help our model learn the parameters of the data, and therefore we helped to avoid the issue altogether. The third step we took was sort of feature selection. This was just to select a group of variables, the most predictive ones. So this is like sort of going to the final stretch. How we did that was we created a subset of the most predictive features. We selected variables using a formula called the lasso regression, and we use that in Jupyter. Essentially what it does, it takes non-informative variables and transforms them to zero, so that we're able to have a randomness within the model, so that I'd be able to identify variables and remove them from our final model, the ones that aren't predictive and the ones that do predict the highest amount of who predict the sales price the best, essentially. And then after that, we went into model building, and ultimately when we used this identified subset and we ran it through the lasso regression, we were able to predict house price to around 163K in Iowa with about 83% accuracy on our final train set. We evaluate this prediction with respect to real sales price, and we can see in our linear model displayed a normal distribution. So we actually were able to graph the line graph, and we're able to see all the different data points of all the variables, seeing if it was normally distributed. We also saw the distribution of errors, which essentially is just the mean squared error. You could say it's like the average squared difference between the estimated value that was predicted from the variable and the actual value. We saw that it didn't stray too far away, so all of it stayed within a normal distribution chain, and therefore we can determine that our model was ready for deployment. Next slide, please. And now Katherine will be talking about our target.
Yeah, so as Justin mentioned, what we're trying to do is make sure that we could efficiently predict the sales price. So we'll go into the next slide really quickly to go over some of the results. So one more, please. Yep. Perfect. So the model that we built, we're able to predict housing prices or sale prices with about 83% accuracy, which is pretty good when, taking a look at a lot of data. And then also we were able to answer a lot of our initial questions along the way. The questions that we shared in the beginning weren't necessarily the extensive list, but just to give you a little bit better of an idea of the things that we were thinking and how we were trying to analyze all the different variables and components before diving in. So we were able to find that the top 3 variables that made the most impact were the above ground living area in square feet, the overall quality, as well as the neighborhood. So variables that we didn't necessarily think about in the beginning just because we didn't exactly know how they played into the analysis. And also the least important variables and how many variables that need to be trimmed in order to minimize overfitting. We found out that about 60 of the variables that we had in the data set had absolutely no or little to no impact on the model itself. So that gives you a little bit better of an idea of the steps that we had to take and the things that we had to eliminate to be able to get our 83% accuracy. Next slide, please. So one of the things that Kun did, other than focusing on teaching us Jupyter notebooks and Python and really laying that foundation, is he gave us a really good understanding of the data science field as a whole. And so as you can see here, there are 3 main focuses when it comes to data science. And a lot of these roles interact, interchange, and overlap in general, because you have the algorithm deployment, so where your ML engineers, some machine learning engineers, your data scientists work with the algorithms, and a lot of coding. And then you have your inference focus, where that's where a lot of the mathematics happen, the statisticians and the econometricians. And then you also have the analytics portions where you're analyzing the data. But we want to make sure that that all of these 3 focuses are so complex and they work together within the whole field in general. But we did want to point out that within the analytics field, that tends to be a little bit more focused in terms of what they're analyzing. So you have your business intelligence and your business analytics. You have your data analysts, your product analysts. You also have operation analysts, market analysts, a lot of those components within one company. Next slide, please. So we wanted to recap everything and kind of talk about our project and all the things that we learned. So we put together this slide to give you an overall idea of what we learned, not only from our track, but from participating in the program as well. So me specifically, I really enjoyed learning more about the data science field from Kun. I think I got a better understanding and a good foundation in terms of what that looks like, as well as a good foundation for Python and machine learning for other individual projects. Justin and I have worked together this entire time, and we're really excited to continue to work together outside of the program as well. So we have a couple projects that we'd like to work on individually and together. With my experience in the CCE program, I think I learned a lot more about the importance of networking and establishing that working professional network aside from your personal friends and colleagues, and then also the power of mentorship. So throughout the program, I've had really great conversations with Kun, and he's always been very available and communicative and setting time aside from us. And aside from Kun, a lot of the other mentors have also set some time aside and really taken the liberty to reach out and make sure that everything that we need is taken care of and really be giving in terms of their time and their effort and their recommendations. And so I want to say thank you to all of those out there who did. But yeah, I'll go ahead and hand it off to Justin to finish it up.
Yes, and my final thoughts from what we learned from our experience. For me specifically, I just got to learn the full scope of the data science field. You saw that sort of graphic earlier with the the whole table with the connected with having the inferences and also having the data analysts and also having the data scientists. It's all sort of just a huge field. There's so much opportunity, and learning that whole entire scope was just amazing. From Kun himself, I mean, he was obviously very knowledgeable about it, and I really appreciate him taking the time out of just teaching us data science to actually talk about the entire industry. Along with that, we learned how to develop a machine learning model pipeline. This is my first one. I believe it's also the first for Katherine, so we're very grateful for that. And I also personally got to build my networking skills, not just through Kun's track, but also just through CCE. It really pushed me to really just communicate better, talk to more people, network with professionals. And it was a great experience, honestly. And finally, like Katherine said, we plan to hopefully do more projects in the near future. And I'd be happy to work with her with any other data science project we may see fit. But yeah, next slide. So again, thank you again for listening. And I believe John said we have questions at the end, correct?
Yeah, thank you, Justin. Thank you, Catherine. That's a very impressive presentation, and I'm sure everyone has a glimpse of what data sciences field will look like. Yeah, so please keep your questions at the end or type in the chat.